Hello everyone, so welcome to another Leetcode question. In this question we are working on a palindrome number. Whether given an integer x, we have to return true if the number x is a palindrome integer. Let's go through few examples to understand what is a palindrome number. So if we have a number 1 to 1 and when we reverse it, the reverse of 1 to 1 will again look like a 1 to 1. And when these two numbers are the same, in that case, we will return true. Now, let's take a look at this negative integer. The reverse of negative integer, the negative 1 to 1, will look like 1 to 1 followed by a negative sign. In this case, these two are not equal to each other, or at least the representation of these two integers or these two entities are not equal to each other. So in this case, we return false. Now let's take a look at another integer 10. The reverse of 10 will look like 0, 1, which basically is 1. And since it is not equal to each other, in this case also we return false. In this case, we have been given in this question, a follow-up has been asked that can we solve it without converting the integer to a string. So, checking whether the integer is a palindrome or not, if we convert that integer to a string, we can simply check if the string is palindrome or not, and based on that we can return true or false. So this is actually the brute force solution as well. Let's discuss on this. So in the brute force solution, let's say we have the integer 1 2 3 2 1, and if we convert it to a string, it will look like this: 1 2 3 2 1. What we can do, we can keep a left index at 0 and we can keep a right index at the length of the string -1, which is 4. And then while left is less than right, we will increment the left and decrement the right. And whenever we check a case where this element or the character at index left is not equal to the character at index right, if they are not equal, then in that case we can safely return false. Otherwise, if we come out of the loop where we will increment the left by 1, we will decrement the right by 1. Okay, so whenever we come out of the loop, it means that all the characters are at index left and index right are equal to each other. So in that case, it is a palindrome. So we can safely return true in that case when we will come out of the loop. Now in this case, the time complexity will be log 10n. Why log 10n? Because if x is an integer, log 10n represents the number of digits in the integer. Okay, so my left is actually linear to the number of digits in x, right? So that's why the time complexity will be log 10 of x. Now what will be the space complexity of this problem? The space complexity will also be log 10x because we are creating a string. We are creating a string out of x, right? Now what is the space that x is occupying? X is occupying the number of digits present in it, which is equal to the log 10x, right? If the maximum number is 99999, log 10 of x is basically 5 in this case, right? That's why we can say the auxiliary space that we created from integer to string is equal to the number of characters or digits in the integer x. Now, is there an optimized solution? Yes, there is. In terms of time, we can see that we can't do much, but in terms of space, can we do better? So there is an algorithm for this. As we can say, the first case that comes to mind is that if the number is 0, it's a palindrome, right? So first case, if the number is 0, it's a palindrome, just return true. The second case, when there is a negative number, since the negative number is always followed by a negative sign, reversing the number will look like that number and then the minus. Let's say we had the number x and the reverse of it looks like y, and x was a negative, so x was followed by a negative sign. Then what it will look like? It will look like y by negative. And these two numbers are definitely not equal to each other. So in this case, or in this case, we can return false. Now let's say we have a number 300 and this number is actually divisible by 10, right? So third case is, these are the two cases. The third case is whenever the integer is divisible by 10, in that case we can return false. Why? Let's take a look at these cases. Reverse of 10 is 0, 1, they are not equal. Reverse of 100 is 0, 0, 1, they are not equal. So we can return false here. Reverse of 1000 is 0, 0, 0, 1, they are not equal, so we can return false. Reverse of 90 is 0, 9, again they are not equal, so we can return false. So this was the third case. When the number is divisible by 10, we can return false. And for the 0, we have already made a base case at the top. When the integer is 0, just return true, because 0 is equal to 0. The reverse of 0 is equal to 0. Now let's understand the cases when there is a integer which doesn't fit into the first three cases. In this example, we have like 1, 2, 3, 2 and 1. If you look at this number, what we can do is we can reverse the second half. We can reverse the second half of this number. We can reverse the second half of this number, and we can just check whether if we eliminate this half from the number, what will be the number if we reverse it? It will be 1, 2 and 3, right? And x will be then will become 1, 2. Let's consider that the reverse of the second half of the number is stored in y, and if we can just simply check if x is equal to y or x is equal to y divided by 10, right? This is the case when the number of digits is odd. When the number of digits is odd, we reverse the second half, but because an extra digit will be added to the reverse number, and when we compare it with the x, we can just divide our reverse by 10 and compare it with x, right? So if we had the reverse as 1, 2, 3, if we divide it by 10, it will be 1, 2, and x then become 1, 2, because it is the first half and this y is the second half. In these two cases, x is equal to y, so we can return true. Okay. Now let's take the case of the second half. The x where the number of digits is even. So in that case, our y will become 1, 2, 3. That is reversing the second half. It will become 1, 2, 3. And while doing this, we keep reducing x. We keep dividing x by 10, right? So in that case, x is also now 1, 2, 3. So in that case, when we compare x with y, if they are equal to each other, which means they are palindrome. Now, how do we figure out the reverse of the second half? So what we can do, we can have a ref variable initialized by 0, and while my x number, which is 1, 2, 3, 2, 1, is greater than reverse, which is 0, in reverse, we will keep multiplying it by 10 and add the last digit in the integer. Okay. So initially ref was 0, and then x is 1, 2, 3, 2, 1. So this is how we calculate the reverse of a number. It's very straightforward. There is nothing to tell much here. So what we can do here, then reverse is reverse into 10 plus digit. This is reverse, and then finally x becomes x by 10, right? So after the first iteration, what we'll have, rev is 1 and reverse will be 1, 2, 3, 2. This is the first step. In the second step, what we'll have, reverse is 1 into 10 plus 2, like the digit in the number. So this become 12, and x is x divided by 10. So x become 1, 2, 3. Basically, we are taking this digit as the x modulo 10, right? X modulo 10, x modulo 10, x modulo 10 till my x is greater than reverse, right? So after if we have a while loop where we are checking something like x is greater than reverse, at some point reverse will exceed the value of x, right? So we'll go again for this. Let's say see the third iteration of this. Then we have reverse is 12 into 10 plus x modulo 10, right? So 3. This is the digit. Then x is x divided by 10, which becomes 1, 2. This becomes 1, 2, 3. Now reverse is actually greater than the number itself. So either we can just check if reverse is equal to x or x is equal to reverse by 10. Why? Because the number of digits in this case was odd, and the only way reverse is equal to x is because reverse is greater than x, and if reverse is greater than x and when we divide rev by 10, so we are actually reducing one digit from reverse. And if in that case, so if x is equal to reverse by 10, this means rev is greater than x and we have reduced one digit in reverse, and in that case if they are equal, then we can return true. Or the other case was simply x is equal to reverse. If the number of digits is even and half of the digits in x and the reverse, if they are the same, then we can say they are palindrome. So this concludes our optimized solution. Now let's discuss the time complexity. We already discussed the time complexity for the brute force. For the optimized solution, the time complexity will be the same, but since we haven't created any string or any space, any auxiliary space in the algorithm, the space complexity here will be constant. Now let's do the code walkthrough for this. So as we discussed, the first case is when x is 0, it's a palindrome. So we safely return true. If x is less than 0, it means it is a negative followed by a negative sign. And when we do reverse of it, it will look something like, let's say it was minus of x and we do reverse of it, and let's say it looks like, what will the reverse of minus x? Let's say it is my y minus, but there is no such number, right, where we have a negative sign at the end. So we can return false, right? You can also check with your interviewer what happens with the negatives and what do you expect to be called for whether it is palindrome or not. And then we discuss the third case when x mod 10 is equal to 0. We already know x can't be 0 in this case because we already checked it above. And if x mod 10 is equal to 0, then we return false. So for example 90, the reverse of it will become 09, and this can never be palindrome, right? This number which is divisible by 10 can never be palindrome. And what we did is then we have a reverse where we store the reverse of the second half of x. So this is the algorithm that we written above and computed mathematically, that at the end of this algorithm reverse will either be equal to x or it will be greater than x. Okay, so if it has to be palindrome and the number of digits are same, then x has to be equal to reverse, right? So for example 1 2 2 1, this is the palindrome, right? If it is reverse, the last half of it, this will become 1 2 and the x will then remain as 1 2, and this will be the rev. So in order for this number to be palindrome, x has to be equal to rev, and in this case 1 2 3 2 1, the rev will become 1 2 3. Reverse of this, x was initially this, x was initially this, and after this algorithm x will become 1 2. So when the number of digits is odd, reverse has to be greater than x, and by reducing one digit from reverse, these two, x and rev, should be equal to each other, right? So if we divide rev by 10, then it becomes x is equal to reverse by 10. So this is the two cases where we can say that the numbers are palindrome to each other. And that concludes our algorithm. Thank you.